Now welcome back. Welcome back. Now, sodium hydroxide. So sodium will combine with chlorine to form sodium chloride. While hydroxide plus the hydrogen hydro part, hydroxide and the hydro will combine to form the water part. So any time you have a base, the oxide or the hydroxide part will combine with the hydro part. The nitric acid also have the hydrogen. So anytime an acid reacts with the base, you're going to form a salt and water. So sodium hydroxide plus hydrochloric acid will give us sodium chloride and water. And this is a neutralization reaction. So below are one equation for the reaction between metal oxide and acids. So metal oxides are also types of bases. Metal oxides are types of bases. We have all the hydroxides are bases or alkalis, but not all oxides are bases. Because you have carbon dioxide, which is not a base, sulfur oxide, which is not a base, but all hydroxides are bases or alkalis. But when you come to oxides, the metal oxides are bases. So that's what you're going to deal with here, metal oxide. So for the first metal oxide, a base plus an acid is going to give you salt and water. Calcium oxide plus hydrochloric acid is going to give you calcium chloride plus what we call water. And I will urge you that each and every time you try having your own prediction. When you see this kind of reaction, you start having your prediction because I've given you enough to enable you be able to do this prediction. For example, magnesium oxide plus nitric acid. Know that magnesium oxide plus nitric. So that we are likely to have magnesium nitrate plus water. That's an acid and a base. Magnesium oxide plus nitric acid, magnesium nitrate plus water. Zinc oxide plus hydrochloric acid, we are likely to have zinc chloride plus water. Copper 2 oxide plus sulfuric acid, we are likely to have copper 2 sulfate plus water. So in general, we are having a base plus an acid is going to give us a metal salt and water. Now, so metal oxide, metal hydroxide, and ammonia solution are bases. Anytime you are meeting any of these three, metal oxide. Remember I told you that not all oxides are bases, but metal oxides are bases. Not all oxides are bases, but metal oxides, all metal oxides are bases. Metal hydroxides are bases. Ammonia solution is also bases. Note, endpoint is only attained only when one of the reactant is completely used up. And that's a point I've already told you. Now, what are the properties of acids? Acids have sour taste. For example, if you taste lemon juice, that's an acid. They have a pH value below 7. As I had already shown you in that chart, they have a pH value below 7. Another one, they change litmus indicator from purple to red. Changes litmus indicator from purple to red. Changes phenolphthalein to colorless. Changes methyl orange. So in other words, they are colorless in phenolphthalein. Changes methyl orange from orange to pink. React with bases to form salt and water. Then another thing, they react with carbonates and hydrogen carbonates. They react with carbonates and hydrogen carbonates, and when that happens, what do they form? When they react with carbonates and hydrogen carbonate, they are going to form three things. One salt, second water, and another one carbon dioxide. They react with metals to produce hydrogen gas and salt. This is also a concept we already learned. Properties of bases. Bases have a bitter taste. They have a pH value of above 7. That means from just above 7 to around 14, there is whereby you find bases. Changes litmus paper indicator from purple to blue. Remember, there's a difference between litmus paper and litmus indicator. There's a difference between litmus paper and litmus indicator. Changes litmus indicator from purple to blue. Changes phenolphthalein from colorless. Phenolphthalein will be just down here to pink. So this is the phenolphthalein we've already studied. Changes phenolphthalein from colorless to pink. Changes metal orange. Metal orange is generally orange, the way the name suggests, to yellow. So it changes it from orange to yellow. React with acid to form salt and water. React with acid to form salt and water. Now, we are going to discuss the effect of acid on substances. I'm very sure you walked around, even when you are at home, you can just look at your metallic substances back there at home that are exposed to rainwater, then you can see the effect of acid rain. You can look at your apartment, you can see, you can look at the tiles which have been used to cover your home, you can look at the metallic windows. You are going to realize the effect of acid. Now, in industry, we've got what we call gases that are emitted. And there are three major gases that are emitted. We have carbon dioxide, we have nitrogen 2 oxide, nitrogen 4 oxide, then we have sulfur 4 oxide. So these are gases that when they are released into the atmosphere, they are going to mix with what we call rain water. And when that happens, they are going to form what we call acid rain. And once that acid rain has been formed, it's going to cause what we call corrosion. Corrosion, you find that now, when you look around, you are going to look at the stonework. For example, your apartment there before it's painted. You are going to look at the iron sheets and such kind of things. When you look at them, you are going to find that they are corroded. So we have the roofs, we have metallic surfaces, we have stonework. Look at this one, they are going to be damaged by what we call acid rain, and that's what we call corrosion. Now, another thing, you can inhale this acid that has been released from the industry, and once you inhale, they are going to cause what we call respiratory problems. Some of these acids, once you inhale them and they go into your respiratory system, they are going to cause what we call respiratory disorders, and that is not good for your health. Another thing, we can talk about leaching. You find that when this acid rain is going to fall on the surface of the earth, it's going to start reacting with the minerals, which are on the surface of the earth. And when this happens, these minerals get dissolved. And when they get dissolved, they start moving below into the earth surface, into the earth crust. And once that's happened, you find that the soil that is going to remain behind is going to be devoid of nutrients, not going to lack some nutrients. And when that's happening, you find that it's not going to be suitable for growing of plants, growing of crops, and any other substances. So what are the uses of acid? Carbonic acid is used in inherited drinks such as the champagne, such as the Coke, such as the Fantas, and this is meant to enhance the taste. Hydrochloric acid used to clean metal surfaces, for example, the sink at home, the toilet at home. There's this thing called acid that is being used to clean the surfaces back at home. For example, your toilet is very dirty. that is nothing short of hydrochloric acid. So you find that these substances do get application in our everyday life. Now, so we are going to put an end to today's lesson at applications of acid and bases. So that next time we are going to begin discussing these applications of acid, then we go to bases, then we see what else is there for us to discuss about acid bases indicator. Thank you and have a good day.